Now we're going to look at our second method for solving systems algebraically. This one is to solve systems by using elimination, also called linear combination. A couple of things that we need to look for when we're using this method. We want to make sure our equations in standard form to start with. We want to decide which of the variables we want to eliminate. Do we want to eliminate the x or eliminate the y? And we're going to do that by looking at the coefficients and by adding the two equations together. So I'm going to decide what to multiply each equation by in order to make my coefficients opposites, because in order for them to be eliminated by addition, they have to be opposite. So they have to be the same distance from zero. One's going to be on the positive side, one's going to be on the negative side. To do that, we're going to look for the least common multiple of our coefficients. Alright, once we've made them opposites, then we're going to go to step 3, which is to add the two equations together. That's going to leave me one variable in step 4. I will solve for that remaining variable. And then in step 5, I'm going to substitute back into one of the original equations, and here is original, and solve for the other variable. Let's look at an example. There's my system. They're both in standard form, which means the x and the y are on the same side of the equal sign. And sometimes you need to check to make sure you've got the x's first and the y's second. Okay? Well, then I want to decide which of my variables would be easy to eliminate. Well, I notice that both my y's have a coefficient of 3. So if one was a negative 3, when I added those together, they would cancel out. So I'm going to multiply the first equation by positive 1, which won't change it. So I'll have 5x plus 3y equals negative 19. I'm going to multiply my second equation by a negative 1, and that's going to give me negative 8x minus 3y equals a positive 25. Alright, so now I'm at step 3, which means I want to add the two together. That's going to give me negative 3x. Net positive 3 and negative 3 is 0, so those cancel. Equals negative 19 plus positive 25 is positive 6. So I'm at step 4, which means I want to solve for x. I'm going to divide both sides by a negative 3. So I get x is equal to negative 2. Alright, and then in step number 5, it says go back to my original equation and plug in for one of the variables, or one of the equations, x into one of the equations. So I'm going to put it the first one. So I have 5 times a negative 2 plus 3y equals negative 19. So I've got negative 10 plus 3y equals negative 19. I'm going to move the 10 over, which is going to give me 3y equals negative 9. I'm going to divide by positive 3. So y equals a negative 3. So it appears that my solution is negative 2, negative 3. And remember, when we check it, we're going to plug them back into the equation. And in order for that to be the solution to my system, both equations would have to be true. So I'm going to erase some of this. Let's just erase where I solved for y here. And let's plug it in. If I put negative 2 in for x and negative 3 in for y, do I get negative 19? The answer is yes. If I put negative 2 in for x and negative 3 in for y, I get negative 16 plus a negative 9 is negative 25. That checks. So negative 2, negative 3 is the solution to my system. Again, remember the steps. We want the equation to be in standard form. We decide if we want to eliminate the x and the y. We want to multiply the equations by something so that one of my variables will be opposites, so when I add them they will cancel. And then we're going to solve for the remaining variable. And then we're going to substitute in step 5 back into one of the original equations and solve for the remaining variable. And then of course I like to check to make sure my system, the solution is the solution of the system. Alright, I'm going to give you 2 problems. I want you to see if you can solve these 2 by elimination, and we will check them in class. Bye.